Hello, this is my lab report for Lab 4 Oscillations. We will analyze a video of an elastic pendulum system to obtain information about the position. We will also be using GlowScript to visualize the energy transformations that occur during a simulated model. A brief summary. So we found that the energy principle is true and that our simulated model closely matched our experimental data. Oscillation can be described as something moving back and forth with a regular pattern, like a grandfather clock, for example. And now the energy principle states that in a closed system, energy is neither created nor destroyed. So that means the total change in energy, which is equal to the sum of the change in rest, change in kinetic, and change in potential energy, will equal 0. If the system is not closed, then the change in energy will be equal to the work done on it by the surroundings. So change in energy equals work. And now, important formulas to know for this lab. The change in kinetic energy is 1/2 mvf squared minus vi squared. The change in potential due to gravity is mg delta y. The change in potential due to spring is 1/2 k final stretch squared minus initial stretch squared. And over on the right, you can see the formulas for the forces due to gravity and the spring. And on the bottom, you have the position update formula. Our assumption for the model is that only the spring and gravity, which is the Earth, will be acting on our object, and we're on the surface of the Earth, and we will be using a final velocity instead of average velocity for our position update formula because our net force is not constant. So our system is just an object, and our surroundings are the spring and the Earth. Our initial conditions, the positions on the screen, velocity, we're starting at rest, and time equals 0. For our video analysis, we first have to set up a coordinate axis and a reference lengths. After that, we can go through and manually select all of the points along the object's path. In our program, we first set our constants and our initial position. Then in the iteration, we calculate the net force by adding up the force due to gravity and the force due to the spring. And then we calculate the change in kinetic, potential due to gravity, potential due to spring. We calculate the change of all of those energies, add them up together, total change in energy. Then we can plot all that information, and then we move on to the next time step. Overall, our model pretty accurately matched our video analysis data. As you can see on here, both the x position over time and the y position over time. In these two graphs, the lines for the model and the experiment are very similar. There's not very much difference between them. Here's the graph of our change in energy over time. As you can see, the change in all of the individual energies is extremely wavy. However, when you get the sum of all those changes, it just becomes a flat line at 0. There are some potential sources of error. One of them is human error while analyzing the video, and some more are the approximations that occurred while we were using our model. What does it mean, part 1? For our model, our system included the mass, the Earth, and a spring, and there was nothing in the surroundings. Therefore, we have a closed system, and in a closed system, according to the energy principle, energy is neither created nor destroyed. This is true because, as we can see on the graph, the total change in energy was 0 throughout the whole thing. On screen, you can see the periods of oscillation calculated using the x position data and the y position data. We believe the reason that these is different is because the length of the spring is constantly changing as it gets compressed and then stretched out, and this changing length results in a more complicated behavior. In conclusion, we found that energy is neither created nor destroyed in a closed system, which means that a closed system has no change in total energy, and that oscillation patterns can depend on various factors.